Alright, this video is on how to evaluate piecewise functions. So we're going to evaluate from the graph, and then we are also going to evaluate from equations. But we're not actually going to do these by hand. We are going to type this in on Desmos. So it gets a little tedious, but then once you have your functions typed in, like you can literally type in whatever you're trying to evaluate and just have Desmos do it for you. So we're going to start with the graph. So this is my piecewise graph. So first of all, basically what a piecewise function is different pieces or parts of functions put together to make one function. So as we can see, this part of the function is linear, this piece is quadratic, and then this piece is a constant. All right, so then the way you evaluate from a graph, you do it the way you normally would if you were looking at a regular graph. So the number that's in parentheses, remember that is your x value. So all of these, we're given x, and we're trying to find the y value that goes with it. So f of -8, so I'm going to come over here, -5, -6, -7, -8. So then the y value that goes with that would be -9. F of -5, so x value is -5. We want the y value that goes with that. So there's where x is -5. The y value that goes with that, -6. -2, so -1, -2. Y value that goes with that would be -3. F of -1, so this one is right here. So then notice I've got an open dot here and I've got an open dot there. So remember, what do open dots mean? So they mean that you don't have a value there, so that value is excluded. So since we don't have a solid piece of graph, all we have is open dots, that means that we cannot get a y value for this x value. So when you can't get a value, that means that that point or that piece of your function is undefined. So because there is no solid dot for -1, -1 would be undefined. So number 4, f of -1, that is undefined. So if you only have open dots for a value, then that is undefined. F of 0. So here's where x is 0. The y value is also 0 because we're right here at the origin. So f of 0 is 0. F of 2. So then same thing. So 1, 2. So I've got this dot up here, and then I've got this open dot down here. So I've got a solid dot and I've got an open dot. So as long as you have a solid dot or a solid piece of graph for an x value, you always go with whatever value that solid piece or dot is on. So that's open, so that value is not included. So I come up here, that's solid, so that value is included. So that means that f of 2 is going to equal 4. So you always go with the solid dot if you have one. So if there is a solid dot, you always go with the solid dot. If there is no solid dot and they are only open, then it's going to be undefined. All right, f of 5. So x is 5. So then the y value that goes with that would be -2. And then f of 8. So x value is 8. So 5, 6, 7, 8. Y value that goes with that, also -2. So that is evaluating from the graph. So literally, you look and see, okay, that's the x value, find the y that goes with it. If there are only open dots, like there were on -1, then your value is undefined. If you've got a choice, so if you've got a closed dot and an open dot, you always go with the closed dot when you're evaluating. All right, so that's from a graph. Now we're going to switch over to evaluating from the function. So this is what a piecewise function looks like. So again, we see we've got different pieces. So I've got an absolute value piece, I've got a constant piece, and then I've got a linear piece. So then these values over here, so notice it says x is less than or equal to 1, 1 is less than x, less than or equal to 3, and x is greater than 3. So these are your domain values that you use the function on the left for. So these are your domain. The part on the left is the function. So then there's a specific way that we type this in on Desmos. So notice it says f of x equals, and then there's a curly bracket right there. That part stays the same. So f of x equals curly bracket. So f of x equals curly bracket. And then in general, you always type the domain first. So for my first piece, I would type x is less than or equal to 1. Then you put a colon, and then you type the function that goes with that. So that would be absolute value of x plus 1. So then once you are done with that part, so that's the whole first piece, you separate each piece with a comma. So then you do the same thing. So now we're going to type the domain for the second piece. So 1 is less than x is less than or equal to 3. So domain, colon, now the function for that one is just 3. So I type 3. So that is the whole second part. So domain colon function. And then our third part. So again, we put the domain first. So x is greater than 3. Colon. The function, which is 6 minus 2x. And then once you are done and have written everything out or typed everything, then you close the curly brackets. So on your keyboard, the curly brackets, you hit shift and then it's the 2 keys next to the letter P. So if we were typing this in on Desmos, which we will in a minute, this is what it would look like. So this is exactly what you would type in. So now we're going to do the same thing for g of x. So g of x equals curly brackets. Same thing. We're going to type the domain. So x is less than 2. Colon. The function. So now the function is negative x plus 2. And then we've got our other portion. So comma, x is greater than or equal to 2. Colon, the function for that part. So x minus 2. And then that's the end of my function. So I'm going to close it with the curly brackets. So I wrote it out. This is exactly what you're going to type into Desmos. So if you have not already, go ahead and type that in. And I'm about to type that in too so we can evaluate. All right, so f of x equals, curly brackets, x is less than or equal to 1, colon, absolute value, x plus 1. So that was my first part. So comma, now my next part. 1 is less than x, less than or equal to 3. Colon the function, which was 3, comma, last section, x is greater than 3, colon, the function for that part, which was 6 minus 2x. And then I close my curly brackets. So then it graphs it for you. So then there's the absolute value part, there's your constant part, and then there's your linear part. So then we're going to graph the other one. So g of x equals curly brackets, x is less than 2, colon, negative x plus 2. All right, so that was the first part, comma, the next part, or the last part, so x is greater than or equal to 2, colon, the function for that was x minus 2, and then I close my curly brackets. So that one is two linear functions that happen to meet at a point, so it looks like we've got just an absolute value function. All right, so that is the hard part of doing this. So if you can type them in correctly, then you're almost there. So now we are going to evaluate just using Desmos. So we are going to find what f of negative 3 is. So the cool thing about this is once you have your functions typed in, then in whatever you are evaluating, you can type it in and it will give you the answer. So I have my function f typed in. I wanted to find what is f of negative 3. There it is right there. So my answer would be 2. If I wanted to find what g of 1 is, I just type it in. G of 1, that gives me 1. And then if you want to evaluate crazy stuff, like for example, negative 4 times f of 6 plus 3 times g of 7 minus 2 times f of negative 3. Again, the hard part is just typing in your two functions up here. No matter what they tell you to evaluate, there you go. You just type it in, it gives you the answer. So that one would be 35. So that is evaluating piecewise given your actual functions. That's how you type them in and all that good stuff. So let me finish writing this down right quick. So negative 4 times f of 6 plus 3 times g of 7 minus 2 times f of negative 3, and that equals 35. So then there it is written right there. So we did f of negative 2, we got 2, g of 1, we got 1, and then this crazy thing, we got 35. So again, the way you type it in, domain colon function, comma, domain colon function, comma, domain colon function. So it is always, always that pattern. So domain colon function. And then you do that for however many pieces you've got. So usually it'll be like 2 or 3 times depending on how many pieces. And then you separate each piece with a comma. So domain colon function, that's one part. And then you separate each part with a comma. All right, and that is piecewise.